Hello students! Let's try some problems together. I hope you have your worksheet calculating wave speed, frequency, and wavelength. In order to complete this worksheet, you need to have already watched lesson 2.1 where we derived the equation for the velocity or speed of a wave. The speed of a wave equals the distance the wave travels divided by the time it takes to travel. We derived a second equation that the velocity or speed of a wave equals the wavelength times the frequency. Please watch lesson 2.1 to see where those equations came from and understand all the terms in them. Okay, question number 1. You are given the frequency and the wavelength and asked to find the speed of the wave. Let's use this second equation because we are given frequency and wavelength, and then we can calculate the speed of the wave. I'm going to write the equation again over here because I always like to start with the equation that I'm going to use. The speed of a wave equals wavelength times frequency. And that is a wavelength of 100 meters times frequency of 5 hertz. 5 hertz, well, please remember that hertz means 1/seconds, which is per second. And I'm going to write the units that way so that I can do dimensional analysis. Multiplying and dividing was the skill you learned in middle school. But now in high school physics, you're going to do not just multiplying and dividing, but dimensional analysis, which means you keep the units in your calculation. The final answer is you're going to multiply the numbers together. So 100 times 5 is 500. And then you're going to multiply your units together, which is meters times meters per second. I'm sorry, not meters times meters per second. No, meters times per second. There we go. When you multiply meters times per second, you multiply the numerator and the denominator. So we get meters in the numerator and seconds in the denominator. And that makes sense because I want my answer to be a rate for speed. The rate is meters per second. Remember that speed is distance divided by time. So it makes sense that my units work out to be a distance, meters, divided by time, seconds. Okay, my final answer is 500 meters per second. Now, I'd like you to try number 2 and 3. I'm going to help you with number 4. Number 4 gives you the frequency and the speed, but asks you to find the wavelength. Okay, I'm going to start with my equation. The speed of a wave equals the wavelength times the frequency. And I'm going to plug in what I know. And I know that the speed is 46 meters per second. And I know that the frequency is 27 hertz, but I don't know wavelength. That's the thing I have to find. Okay, let's plug it in. 46 meters per second equals wavelength times frequency, which is 27 per second. Here, you're going to have to remember your algebra skills. There's no way around it. You've got to do math. In order to solve for my unknown wavelength, I need to divide both sides by 27 per second. I hope you remember your algebra teacher teaching you that you have to keep the equation balanced. You have to do the same thing to both sides of the equation in order to isolate your unknown variable. So that's why I'm dividing both sides by 27 per second. Then when I do over here on the right, 27 per second divided by 27 per second cancels out. And I get wavelength equals 46 meters per second divided by 27 per second. We can treat the numbers separately from the units. The units are going to stay together and the numbers are going to stay together. Let me do this math real quick. 46 divided by 27 gives me 1.7 blah, 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 blah. I'm only going to use 2 digits because I'm given only 2 significant digits in the measurements. So I get wavelength equals 1.7. But what about the units? The units I'm left with are meters per second in the numerator and per second in the denominator. In order to understand units, you've got to be pretty good at fractions. What you have is meters per second divided by, meters per second here, divided by 1 over seconds. So you need to do keep, change, flip because you're dividing by a fraction. So keep meters per second the same, change to multiplication, and then flip per seconds to seconds in the numerator. Now multiply straight across. When you do, seconds and seconds cancel out and you just get meters. And that makes sense because we are solving for the wavelength. Wavelength is a length, so units of meters make sense. You must do dimensional analysis in your calculations, and when you've done it correctly, your ending units will confirm that your calculation makes sense. Okay, that was a lot of work to do keep, change, flip with my units, right? Once you get some experience, you'll be able to look at this, meters per second divided by 1 over seconds, and you'll know that because of keep, change, flip, whatever is in the downstairs denominator moves up to the upstairs numerator. So then seconds moves up to the top because of keep, change, flip, and you'll know that they'll cancel out with whatever is in the denominator. In other words, the denominator upstairs cancels out the denominator downstairs when they are the same. So I simply get meters. My wavelength is 1.7 meters. So you've seen how to solve the equation with your unknown here. And you've seen how to do dimensional analysis when you have a fraction of units divided by a fraction of units. Good job. In number 5, I'm not going to do it for you, but I would like to help you with the conversion. Here it says the wavelength equals 502 kilometers. And it gives you the speed of the wave as 100 meters per second. So the wavelength is in kilometers and the speed is in meters. You need to use the same units for length. So you either need to convert to kilometers or you need to convert to meters. Let's convert the wavelength into meters. Please remember that 1 kilometer equals 1,000 meters. 1 kilometer equals 1,000 meters. So we can go ahead and make a conversion factor, 1,000 meters per 1 kilometer. And that equals 1, as you remember from our lessons on conversion factors. So in order to convert 502 kilometers into meters, we multiply by our conversion factor and do dimensional analysis. So 502 kilometers times 1,000 meters per kilometer. When you multiply those and do dimensional analysis, the kilometer in the numerator cancels out the kilometer in the denominator, and you're left with 502,000 meters. So use this for your wavelength. Then you have your speed in meters per second and the wavelength in meters, and you can find or solve for frequency. Take a look at the back of the page. Let's pick one and do it together. How about number 14? It asks you to find the frequency if the velocity of the wave is 120 meters per second and the wavelength is 3 meters. Okay, start with your equation. Velocity equals frequency times wavelength. Now put in what you know. The velocity is 120 meters per second, and that must equal frequency, which is unknown, times wavelength, which is 3 meters. Now, in this, we have to solve for an unknown frequency. If you're still struggling to solve these equations when the unknown is being multiplied by something, try to think back to your algebra lessons, like 120 equals 3x. Now, could you solve for x? 3 times x equals 120. What is the x? To solve this, your algebra teacher told you that you need to isolate the variable, and you have to perform operations on both sides of the equation to keep it balanced. If the unknown x is being multiplied by 3, then divide both sides by 3, and you'll get x equals 40, because 120 divided by 3 is 40. Well, it's the same thing here. That's how you solve these problems. You have to use your algebra skills. So divide both sides of the equation by 3 meters. Remember that we do the same thing to both sides to keep it balanced. Okay, 120 meters per second divided by 3 meters equals 40. But what about the units? The meters here in the numerator gets canceled out by these meters here. If you don't believe me, write it this way. Meters per second divided by seconds. And then you do keep, change, flip. Sorry, there you go. Meters per second times 1 over... Oh my goodness, I made a mistake. This is meters, and I wrote seconds. I'm really sorry. I should get more sleep. I instantly knew that I made a mistake because these units didn't work out. Let me try again. Meters per second here divided by meters. Now do keep, change, flip. And you get meters per second times 1 over meters. And when you multiply straight across, that's meters divided by seconds times meters. And the meters in the numerator cancel out with the meters in the denominator. If you think the dimensional analysis is a little bit time consuming, don't worry, because once you get experienced at it, it's pretty easy. You'll get used to it. Anyway, I'm left with units of 1 over seconds. I'm going to write SEC so I don't confuse it with a 5. The units here that I'm left with is just 1 in the numerator and seconds in the denominator. So that's per second. That's great news because those are the units of hertz, and I'm solving for frequency. Because of the dimensional analysis, I know I got it right. So I got 120 meters per second divided by 3 meters equals 40 per second which is hertz. There's the frequency. Okay, when you do this worksheet, you're going to have to solve for the unknown, and you must do dimensional analysis. Show your units in every calculation and make sure that your final units work out correctly and make sense.